Hi there! In this video we are going to talk a little bit about nanotechnology. We live in a world of increasingly small and large man-made and natural objects, from the Earth's diameter at 12.742 million meters to the Eiffel Tower at 300 meters tall, to the height of an average person at 1.75 meters, down to insects that range from 1 centimeter to tens of centimeters, to the cells at 25 micrometers, and to the nucleotides that make DNA at 0.6 nanometers long. Many of these objects, both man-made and natural, are so small that they are on the nanoscale and cannot be seen with the naked eye. The nanoscale refers to something that is 1 to 100 nanometers in size. A nano is 1 billionth. For example, 1 meter is 1 billion times the size of a nanometer. To put this in perspective, if you were to break 1 inch into 25,400,000 pieces, each piece would be 1 nanometer, and a single piece of paper is around 100,000 nanometers thick. Each hair of an average man's beard is about 80,000 nanometers thick and grows about 1 nanometer in length every second. But what can nanotechnology be used for? Nanoscience and nanotechnology are the study and application of man-made and natural objects that exist on the nanoscale. Nanotechnology can focus on many different topics. It can be used in biology, engineering, chemistry, physics, electronics, and many more. Biology and chemistry can be used to manipulate DNA. Engineering can be used to build functioning machines at the nanoscale, and in electronics, biosensors are being explored on the nanoscale. If we want to be able to make and change things that are so small, what do we do when it is on the nanoscale and we cannot see what we are working with? One microscope that can help to see is called an AFM, or an atomic force microscope. This allows us to be able to see what the surface of a material looks like in the X, Y, and Z directions. For example, if you have ever seen or encountered a butterfly, you may have noticed that its wings both look and feel very smooth. But if you use an atomic force microscope to measure the surface, you find it is not as smooth as we first perceived it to be. A butterfly's wings are made up of many small scales that are made up of longitudinal ridges. When an AFM is used to measure a scale, you can see that these ridges that make up the scales. How does the atomic force microscope actually measure the surface that seems so smooth to our eyes? This microscope has a cantilever, or a beam, that is attached to the microscope on one end. On the other end is a needle-like tip. This tip, however, usually has a radius of 15 to 40 nanometers. In order to measure the surface of the sample, the stage the sample is on is moved under the tip. When the tip rises and falls due to bumps and ridges, it measures any height changes occurring on the surface. These height changes can be recorded using optics, where a laser is reflected off of the end of the cantilever and into a mirror. This mirror reflects the laser into a photodetector that records each change in height into the computer that the AFM is connected to. The stage can be moved in small increments in order to measure the desired area. The AFM is only one of many devices that can be used to view and measure materials on the nanoscale. Some, like the environmental scanning electron microscope, even allow you to be able to measure in liquids and to measure biological materials. Just think about the world around you. Everything you see is made up of even smaller building blocks that we cannot see. Objects we view as smooth actually are made up of many bumps and ridges. There are many things that we do not know of because they are too small for us to see, and nanotechnology can help us to gain this knowledge.
Created using Powtoon.